Hello everyone. Today I am going to discuss another method to solve simultaneous linear equations, that is the LU factorization method. Now why this method is called LU factorization method, that I will tell you as the video proceeds, but right now I will show you an example, because to understand this method clearly there is no theory to understand, but rather you need to see an example and get the concept of it. Now I have been given three equations: 8x1 minus 3x2 plus 2x3 equals to 20, 4x1 plus 11x2 minus x3 equals to 33, and 6x1 plus 3x2 plus 12x3 equals to 36. Now what I will do is, I will do the same steps as I had done in matrix inversion method. That is, I will construct three matrices A, B and X. Now A is nothing but the coefficients of the variables. A is nothing but coefficients of the variables 8, 4, 6, minus 3, 11 and 3, 2, minus 1 and 12. B is nothing but the constant terms 20, 33 and 36. X is nothing but the variables themselves, x1, x2 and x3. Now what I will do is, I will factorize the matrix A into multiplication of L and U. L and U are two matrices. Their multiplication will give us A. I will just assume that. So A is equal to LU. Now, as I am doing this factorization, that is, I am breaking A into L multiplied by U, therefore the method is known as LU factorization. Okay. Now, what is L and what is U? L is nothing but, L is a matrix, that is L11, L21, L31, this will be L22, L32 and this will be L33, and the rest elements will be 0. And here U will be, this is capital L, and U is nothing but 1, 1, 1, 0, 0, 0, U12, U13 and this one is U23. Now these are the matrices L and U. Their multiplication will give us A. Now from these three matrices A, L and U, we will calculate the values of L11, L21, L22, L31, L32, L33, U12, U13, U23. So we will get the values from this expression. Now let us calculate the values. So LU is equals to A. Therefore we will just multiply it from here. Now multiplication of matrices, if you remember, then L11 into 1 plus 0 into 0 plus 0 into 0, that gives us L11 equals to 8. Then L11 into U12 plus 0 into 1 plus 0 into 0, that gives us U12 is equal to minus 3 by 8. Then L11 into U13 plus 0 into U23 plus 0 into 1, that gives us U13 is equals to 2 by 8, that is 1 by 4. Now we will continue with the second row of L. L21 into 1 plus L22 into U12 plus 0 into U13, that gives us L21 is equal to 4. Next, L21 into U12 plus L22 into 1 plus 0, that gives us L22 is equals to 25 by 2. Then L21 into U13 plus L22 into U23 plus 0, that gives us U23 is nothing but equal to minus 4 by 25. Similarly, we will get L31 equals to 6, L32 equals to 21 by 4, and L33 equals to 67 by 50. So we got all the values that were unknown here, and so we will write the matrices with their values. So we have written the matrices L and U with the values that were unknown. So L is equal to nothing but 800, 4, 25 by 2, 0, 6, 21 by 4, 567 by 50, and U is nothing but 1, minus 3 by 8, 1 by 4, 0, 1, minus 4 by 25, 0, 0 and 1. Now, if you remember this equation, or rather expression Ax equals to B, from this we had derived that x is nothing but A inverse B in our previous video, that is the matrix inversion video. Now in this video we will not do this derivation, we will just continue from this expression. Here we will again factorize B into Ly, and again we will factorize y into ux. Now x you already know, that is the matrix containing the variables themselves. Now y, what is y? Y is nothing but a new matrix containing a new set of variables y1, y2 and y3. Now what we will do? We will just solve these two expressions and we will get the values of x. Now first of all we will solve the value of we will solve this expression B equals to Ly. So we will write the expression in matrix form. L, that is 8, 4, 6, 0, 25 by 2, 21 by 4, 0, 0 and 567 by 50. This multiplied by y, that is y1, y2 and y3, is nothing but equal to B, that is 20, 33 and 36. So we will just solve this expression in the matrix form and we will get the values of y1, y2 and y3. After getting the values of y1, y2 and y3, we will solve this expression to get the value of x. So now let us solve this expression. Now 8y1 is equals to 20, therefore y1 is equals to 5 by 2. Now 8y1 is equals to 20, therefore y1 is equals to 5 by 2. 4y1 plus 25y2 by 2 is equals to 33, therefore y2 is equals to 46 by 25. Last, 6y1 plus 21y2 by 4 plus 567 by 50 y3 is equals to 36. Therefore, y3 is equals to 1. So, we got the values of y1, y2 and y3. We will just put these values in this expression and get the value of x. So, we have put the values of y1, y2, y3 in this expression, and therefore we will calculate the values of x1, x2 and x3. Now x1 minus 3 by 8 x2 plus x3 by 4 is equals to 5 by 2. Therefore, let us calculate the value of x3 first. 0 into x1 plus 0 into x2 plus x3 is equals to 1. Therefore, x3 is equals to 1. Next, x1 into 0 plus x2 into 1 minus 4x3 by 25 is equals to 46 by 25. That means x2 is nothing but 2. Then the last value x1. So x1 minus 3x2 by 8 plus x3 by 4 is equals to 5 by 2. Therefore, x1 is nothing but 3. So, we got the values of x1, x2 and x3. Therefore, x1 is equals to 3, x2 is equals to 2 and x3 is equals to 1. So, this was the LU factorization method. Now, if you ask me, then I will suggest one thing. Maybe this method is a bit lengthy method, but this method has less chances of being wrong or bringing out wrong values or answers. So, I will suggest that to solve simultaneous linear equations, if you have time in your exams, please use this method to get almost accurate and perfect answers. Thank you.